Welcome. So this question says a point that is 5 meters from a turning axis of a rigid cylinder has an angular velocity of 3 radians per second. What is this point's tangential speed? So basically, let's visualize it. Here's a rigid cylinder, and here's a point, and we can think of this point as having a V tangential. If you're a car going around a circle, this would be your speed going directly in front of you. We could also think of this in terms of a omega, the rotational speed. What do we know about this? We know this is 5 meters radius. There's a turning center, and we know that this omega is equal to 3 radians per second. So it's asking for a straightforward translation from angular velocity into the equivalent tangential velocity. And so we need to find a relationship that links these two things, and what we find is that our V tangential is equal to our angular velocity times our radius. And this is actually part of a family. If you think about it, we began by saying that the angle in radians was equal to the arc length over the radius. And if I rearrange this, this would be S is equal to theta r. So by analogy, I'm not justifying it any more than that. I'm saying and the S was if you like, a linear measurement around an arc. Well, okay, I'm going to say that V is equal to omega r, and later on I'm even going to say that A is equal to alpha r. So the angular bit is the bit with the r on the side of it. That's literally how I remember it. I say angular. The r is on the side of it. So this could be tangential acceleration. This would be tangential velocity. And this could be the tangential distance, if you like. So over here we can say, well, in this case then, we want to find V tangential. So we'll say V tang is equal to omega, which is +3, times the radius, which is 5. So V tangential is equal to +15. And the units, what will the units be? Well, it's a tangential velocity, so it would be 15 meters per second. So just a straightforward conversion from angular to from rotational to linear, and from linear to rotational. Get used to going backwards and forwards on that. There we have it.